Tonight we're trying to find the remainder when we divide a very huge number squared by 29. So we're trying to find this value r. The approach here will be to reduce n first and then square everything at the end. That's a little bit easier than squaring this whole trinomial and getting 9 terms and having to reduce each of those 9 terms. Now an equivalent way to write our problem is just like this. N squared is congruent to r modulo 29. And so we get something for free sort of in this problem. Okay, we're taking a look at n. Here's our original expression n. There's a result called Fermat's theorem, and what it says is this. It says if you have any base raised to a prime power minus 1, like this, in other words, the exponent is p minus 1, that's going to be congruent to 1. Mod p. Now the assumption we're making is that p and a are relatively prime. Some people say a does not divide p, but in any event, as long as a and p are relatively prime or coprime, we have this nice result here. And so you can see this is exactly in this form for the prime 29 minus 1. Okay, let me write that right above there, folks. So 29 minus 1 is 28. And so we get 4 to the 28th is 1. That's where this 1 comes from right here. So we kind of get that for free. And y'all, this is called FLT, Fermat's little theorem. Fermat was a French lawyer, mathematician, hobbyist, philosopher, a bunch of stuff. Now, so it remains to reduce 11 to the 25th and 2 to the 26th. Again, once we do that, we'll have to square that modulo 29 and see what we get. So I'm going to do it for one of them. I'll work with 11 to the 25th and leave 2 to the 26th for y'all because it's very similar. Now, Fermat's little theorem gives this, just like 40 to the 28th is congruent to 1. FLT gives us 11 to the 28th is congruent to 1. Now, here's something quite useful that you'd have to note on your own, or not unless you have another approach, is 8 and 11 are kind of like reciprocals. 8 times 11 minus 1 is 87, but that's divisible by 29. So 8 and 11 are called multiplicative inverses modulo 29. Now, notice that's just because 29, let me write this off to the right here. And some calculation is required here. This is stuff I did before I did the video here, but 29 divides 88 minus 1. And that's what 8 times 11 is, right? 8 times 11 minus 1. Okay, y'all, again, 88 minus 1 is 87, and 3 times 29 is 87, right? So that's 8 times 11. So again, these are just like in fractions, you know, like 4/3 times 3/4 is 1 in the regular number system. In modulo 29, these guys are reciprocals of each other, okay? So we're going to use that successfully. Notice how we start with the 28 right here. Notice how it becomes 27 because we multiplied both sides by this. But that wipes out one of the 11s, right? But it brings the 8 to the other side. It's hard to get used to it, but it's really identical to working with real numbers and multiplying through by or dividing by something. You know, you're just reducing it down because of this truth. So you get 11 to the 27th is congruent to 8. The 8 coming from here. And the fact that 8.11 is congruent to 1 gets rid of one of the 11s over here, you see. Pretty slick. All right, and now we do it again, multiply through by this, and you get 11 to the 26 is congruent to 64, but 64 minus 6 is 58, which is 2 times 29, right? And so finally, we do it one more time, and you get this. Again, 8 times 6 is 48, all right? But 48 minus 19 is 29, right? So you see, just like that, we've gotten it to this level where we have n is congruent to 19 plus 1. Then we have the 2 to the 26. Now, I'm going to go ahead and pencil that in the name of time. What the result you can do to get the very same thing is note that, and this is a nice exercise if you're not familiar with modular arithmetic, but 2 times 15, 2 and 15 are multiplicative inverses because 2 times 15 is 30 and minus 1 is 29, right? So 2 times 15 is congruent to 1, and you'll use that back just like I use 8 times 11 is congruent to 1. And when you do that, you should get, this reduces down to 22. And again, I'll just write that in there, folks. And again, I just don't want to avoid the clutter. Again, if you enjoy this kind of stuff, you can see why this goes, because you would work your way down from 2 to the 28 is congruent to 1 in much the same way I did right in the above line. So 2 to the 28 is congruent to 1, and you would multiply through by this twice to get this knocked down to 26, and you would find out 2 to the 26, you would find out that that was congruent to 22. Okay, so now let's keep going here. Now this is 19 plus 20, so this is congruent to n. We are interested in n squared, but we're just about done here. So 19 plus 1 is 20. This is 42, right? So 42 is congruent to 13, right? 42 minus 13 is 29. So let me write that down. So 42 is congruent to 13. Okay, so we get n is congruent to 13 mod 29. Let me just write that. So we've concluded that n is congruent to 13. And again, it's understood that we're doing modulo 29. But we want to know, the question is, what is n squared, right? We're looking for n squared. What is the remainder when you divide n squared by? Here we go. Let's get back down here. So we got to square this. Get that working again. Okay, so there we go. So we have to square this, folks. And so what you would get is, let me just come over here, n squared would be congruent to 169, right? 13 squared is 169. Okay, but let's see, 169, I believe if you do the calculation on that, you get 24, I believe. Let's see here. Yeah, 169. Let me write. I'll just go ahead and write this down and then show you the arithmetic. This is congruent to 24 since 169. And I think you just have to do this one directly. 169 is equal to 5 times 29 plus 24. 5 times 29 is 145, and 145 and 24 is 169. So 169 is 5 times 29 plus 24. Like that. So y'all, that's our answer right there. And again, I hope it's not too much trouble for you guys to come up here and check how 2 to the 28 gets reduced down to 22 using this arithmetic certainty. 2 times 15 is congruent to 1. Again, these are called multiplicative inverses. So final answer is 24. So let me come up here. The R is equal to 24. All right. Thanks for viewing.